Good morning all. Today I dhiman is going to give presentation on the topic an extensive approach for interframe video forgery detection. My paper ID is 3972 and the name of the track is Artificial Intelligence and IoT and my co-authors are Dr. Hakam Singh and Dr. Abhishek Thakur. The contents which I am going to cover are introduction, forgery detection techniques, forgery methods in digital video, proposed technique, results and comparison, conclusion, and after that, references. Image forgery means manipulation of digital images to conceal some meaningful information or use information of the image. There are cases when it is difficult to identify the edited region from the original image. The detection of a forged image is driven by the need of authenticity and to maintain integrity of an image. A digital image can be forged by various attacks like rotation, scaling, resizing, addition of noise, blurring, compressing, image splicing, copy move attack, etc. In the diagram below, in the figure below, this is the figure of image forgery. Here, I1, I3 and I4 are the original images, whereas I2 and I5 image is an forged image in which copy move forgery is done. There are various forgery detection approaches like image forgery is further of two types like active and passive forgery. Further, active forgery is divided into digital watermarking and signature, and passive forgery is divided into two categories, which is forgery independent and forgery dependent. Further, forgery independent is like image touching, and image splicing and copy move forgery comes under the category of forgery dependent. Now, digital watermarking and signature are examples of active approaches. And in contrast to these approaches, passive image forensic technique works in the absence of a watermark or signature. Further, there are various forgery methods in digital video which are spatial forgery and temporal forgery. Spatial forgery is also known as intraframe forgery. In this form of manipulations involves altering the visual elements of a video frame along the XY axis. Spatial tampering can occur by modifying the adjacent pixel bits in a video sequence or within a single frame. Spatial tampering can be performed at different levels including pixel, block or scene level. The technique falling under this category of manipulation includes crop, replace, morphing, object addition and deletion also. Whereas temporal forgery, which is also known as interframe forgery, involves manipulating the video concatenated sequence of frames. The progression of temporal tampering occurs across the time. It primarily influences how the gadgets record the time sequence of visual data. Tampering occurs at the frame level and involves adding, removing, and shuffling of frames. Means further temporal forgery is categorized into frame insertion, frame deletion, frame duplication, and frame shuffling. Now the proposed technique which I have used is a 25 layer deep convolution neural network in which the input image is normalized by using 114 into 3, where 114 is the length, 114 is the breadth, and 3 represent the channel, that is red, green, and blue color. The 2D convolution layer is placed on the layer 2 layer 5, layer 8, layer 11, 14 as well as on layer 17. After that, relevant layers are placed on layer 3, 5, 9, 12, 15 and 18 which calculate the node output in the neural network. The 2D max pooling is placed on 4th layer, 6th, 10th, 13th, 16th and on layer 19th. Now the 4 layers that are 20, 21, 22, 23. These are fully connected layers in the network, meaning individually node is connected to every other node in the neural network. In the last 25th layer is softmax activation function is used as an output to classify whether the images are authentic or forced. After that, Adam Optimizer is employed during the training phase as it requires low memory and outperforms on large datasets. The initial learning rate is 0.001 with an L2 regularization factor of 0.004. A learn rate drop factor of zero point 0.5 and learn rate drop period of 10 are utilized. Then the data is shuffled after every epoch. We are using valid trained GS to train our model and validation data to validate the model. 3 is validation frequency. We are providing 1000 max epochs with 100 min batch sizes. Verbose is used to display training progress information. After that, we have done the training progress in deep neural network training process for video forgery detection, and we have taken video forgery dataset in which there were some authentic. We have taken some authentic as well as forged images. After that, when we have taken the authentic images, we have classified them as an authentic, and when we have taken forged images, then we have classified them as an forged images. After that, we have done the visual forgery classification. After that, deep neural network transfer training video frames for video forgery detection is being done, and then deep neural network transfer training process for video forgery detection is also being done. After that, the results comes the result section in which accuracy and loss graphs are presented to analyze the performance of different techniques. The accuracy graph illustrates the changes in accuracy over min batch iterations and validation steps, providing insights into the model's ability to classify data correctly. On the other hand, the loss graph depicts the variation in loss values during min batch iterations and validation, indicate how well the model minimizes the errors. Now, in this figure 4, this results the accuracy graph between min batch and validation. Means min batch accuracy and validation accuracy is being validated. It shows that more is min batch accuracy, the greater is the validation accuracy. In the next graph, we have plotted loss graph between min batch and validation, which shows that the greater is the min batch loss, validation loss is also higher. This graph is linear in high order min batch loss. After that, this table is presents as a comprehensive analysis of each step, ranging from traditional to advanced algorithms. It it highlights the details and provides a comparison between them comprehensively. Like in the reference number 2019 has used the data technique and dataset in which algorithm is used on SELFA and SYSU object forge dataset is used, and here accuracy average accuracy was 88.12 and 90.64. After that, the research paper into 2022 by Van Nahan, uh, it has researched the MDD algorithm. It has used MDD algorithms and blocked the snuffling transformation approach in which AUC is 0.931, ACC is 0.861, and the loss decreases from 0.84 to 0.78. In next paper, a morphological filter detector is used in UCIT dataset its accuracy is equal to or above 76.8 in all datasets. The next paper, Cassia V1.0 dataset, is used in which accuracy was obtained as 73.3%. Then in next paper, selective perception network was used on forensic data, in which FI score for ISO speed was 100, 800 and 3200 respectively, 84.33, 82.86 and 80.13 respectively. In a proposed technique, we have used deep convolution neural network with transfer learning rate, and the accuracy for the validation set is 90.87 and 90.33 is for the training set. Then comes the conclusion. The increasing prevalence of manipulated videos across various domains highlights the critical need for effective video forgery detection. A paper presents a comprehensive investigation that addressed the diverse challenges faced in previous research studies. Recent advancements in neural network based approaches have shown remarkable efficiency in detecting image forgery by uncovering concealed characteristics with images, thereby enhancing their accuracy. Paper proposes an extensive interframe video forgery detection approach. The primary goal is identifying and detecting manipulation between frames in a video sequence. The report examines techniques for detecting forgeries in images and the challenges posed by interframe and intraframe fakes in forgeries in videos. Emphasis is placed on frequently utilized dataset in this field, which can assist new researchers exploring the study area. Simulation result effectively shows the efficiency and robustness of the anticipated approach, emphasizing its impressive accuracy in detecting interframe video forgery. Contribution to the field of visual forensic introduce a valuable method for validating the authenticity and integrity of a video content. Then these are the references which I have used during my research. I have used 27 references which I have used in my research. So thank you. Have a nice day. Thank you, sir.